In this video, we're going to be simplifying expressions using rules for exponents. So let's go ahead and get started. I'm going to start off nice and easy with this example. A to the 8th times b to the 7th, all raised to the 5th power. Now, one of the properties that we have about exponents is this. We know that when we have something of this form, a product raised to a power, then what we do is that we raise each factor to that power. Okay? Now, the more of these you do, the more you can kind of skip some steps. But first we have this. We're going to take a to the 8th and raise that to the 5th power, and then we're going to take the other factor, b to the 7th, and also raise it to the 5th power. Okay? That's just using this little property that we have, that when you have a product raised to a power, you get this form. One of the other properties that we have is this, is that when you have x raised to the m power, and then raised to the nth power like this. A power raised to a power means that you will multiply those powers. And that's exactly what we're going to do here. So, we have a to the 8th raised to the 5th. So according to this property, we're going to multiply these guys. So 8 times 5 is 40. We're going to do the same thing over here. 7 times 5. And we get b to the 35th power. What we need to understand about exponents is that when we have a to the 8th, that means we have 8 factors of a all connected to each other. So the a times a times a, you have like 8 a's all, written out. This power of 5 means you have 5 sets of 8 factors of a. So if you have 5 sets of 8, you have 40 factors of a altogether. And the same thing here with the b. You have 5 sets of 7. So altogether, that's going to give you 35 factors of b. All right? And let's look at this next one. We have x to the 5th power, y to the negative 3rd, z to the 9th, all divided by x to the negative 8th, y to the 15th, z to the 4th. Okay, so we have a couple of different ways of doing this one. And you just need to find what is most comfortable to you. Now, properties for exponents, you've got a couple of things to look at here. One of these is that when you have x to the m over x to the n. So if you have division going on, and these guys have the same base, then what we can do is that we can subtract the top power minus the bottom power. Okay, so that's one little property that we have. And then we also have this thing that says x to the negative n means 1 over x to the n. And really when it comes to negative powers, it just means that you're doing the reciprocal, which means you put it on the other side of the fraction bar. So, let's do it this way. Now, this is not the way I recommend, but this is one way of working this out. And let's use this quotient rule. So the quotient rule is going to say that you have x's right here. You've got 5. So I'm going to use parentheses here just for emphasis. So that's 5, the top power, minus the bottom power, which is negative 8. And it's important that you put these guys in parentheses. That way you know where your signs are. The quotient rule says that you're doing subtraction. That's what this guy is right here. This negative 8 is because of the power that you see here in the denominator. So yes, you've got 2 negatives, one from the quotient rule and one from the sign of the power. And right next to this, you're going to have y, and so you have negative 3, so that's the top power minus the power in the denominator, which is 15. And then finally we have z, so that's the top power 9 minus the bottom power 4. And we're just going to clean this up. Make sure that you do pay attention to your signs. You have minus minus 8. So this really becomes a plus. I'll just write that up here. So that's a plus. So 5 plus 8 is going to give us x to the 13th. And then here, you have negative 3 minus 15. So both of these guys really are negative. So combining a negative 3 and a negative 15 is negative 18. And then finally we have z. 9, well, it's just 9 minus 4, so that is 5. Now, before you go on and box this answer, you need to understand that we're not allowed to leave negative powers. So anytime we have a negative power, that's where this little property comes in. And so it says when you have a negative power, you just move that into the denominator and you change the sign of the power. So for this, we're going to have x to the 13th and z to the 5th power, but we put this y to the 18th in the denominator because it was a negative power. Okay? And that's, I would say that's all we have to do. Now this is, again, not the way that I would have chosen to work this problem. Okay? Let me show you what I tend to do. All right. So let's do this again. So when I have a problem like this, one of the first things that I do is that I rewrite everything so that I only have positive powers. Once the powers are positive, then the rest of it is a pretty simple exercise. Okay? So here's what we have. We have a couple of factors that have negative powers. So we have this guy right here, x to the negative 8th. So I'm going to circle him, and I'm going to draw in arrows showing where he goes. So when you have a negative power, you put it on the other side of the fraction bar, and you're going to change the sign of the power when you make that change. And then I have another guy right here, y to the negative 3rd, and I'm going to move him down into the denominator on the other side of that fraction bar. So I'm going to rewrite everything. Now I didn't do anything with x to the 5th, so it stays right there. I also have z to the 9th in the top that didn't move. In the denominator I've got these two guys. So I have y to the 15th and z to the 4th. And now what we're going to do is we're going to rewrite those factors that had a negative power on the right side of the fraction bar so they now have a positive power. So what I have here, circled in orange, x to the negative 8th goes into the numerator as a factor of x to the positive 8th, and y to the negative 3rd goes into the denominator, so this is times y to the positive 3rd. And now it's just a matter of cleaning things up. So if I look at my factors of x, I see that they are both here in the numerator. I have x to the 5th, x to the 8th, so I have a total of 13 factors of x. When I look at the y factors, they are all in the denominator. So even though it's not written, that is multiplication here for these guys. You have y to the 15th, you have y to the 3rd. So 15 and 3 gives me 18 factors of y. And when it comes to z, you've got to figure out where do you have more factors of z, because these guys are on opposite sides of the fraction. So if you look here, just looking at the z's, you see that you have more factors of z in the numerator, and the difference between 9 and 4 is 5. So you have 5 more factors of z in the numerator. So it's the same problem, worked a different way, and you get the same answer. Okay? And that's one of the great things about properties of exponents, is that a lot of times there's more than one way to work these problems. All right, let's try a couple more while I've got you here. All right. So let's try 3x to the negative 8th, y to the 5th, all raised to the negative 2nd power. So what we saw earlier is that when you have a product inside raised to a power, this power is going to apply to each factor that you see in here. Now, the trouble that a lot of students run into is that they don't see all of the factors. They see the x and the y, but they don't see the 3, and they don't treat it as a factor like they should. So this is 3 times x to the negative 8th times y to the 5th. So when I work this out, this means that I'm going to have 3 raised to the negative 2nd, x to the negative 8th raised to the negative 2nd, and then y to the 5th raised to the negative 2nd power. Now, here's one of the little problems that we run into, is that we can't really do 3 to the negative 2nd right now because it's a negative power. So we're going to take care of that guy here in just a moment. Right now I want to work on these powers. So as we just showed earlier in this video, a power to a power means we multiply. So negative 8 times negative 2 gives me x to the 16th. And then 5 times negative 2 is going to give me y to the negative 10th. And something we saw in the last problem is that when you have negative powers, so 3 to the negative 2nd, y to the negative 10th, if you have a negative power, you put it on the other side of the fraction, or you do the reciprocal, the same thing. So you might say, but there is no other side of the fraction. Well, this is all understood to be over 1. So we're just going to move these guys into the denominator. Don't mess with x to the 16th. X to the 16th already has a positive power, so you don't need to do anything with that guy. Just leave him in the numerator. When this goes into the denominator, this becomes 3 to the positive 2nd, and this becomes y to the positive 10th. And then we can finish this, because first of all, you want to make sure that you don't leave any negative powers, and then you want to make sure that any numbers raised to a power get evaluated. So 3 squared is 9, and then we have y to the 10th. Okay? So we applied a power to a product. So this power of negative 2 gets applied to each of these 3 factors. Powers to power means you multiply. And then when you have negative powers, you put those guys in the denominator or the other side of the fraction bar, depending on where they start. And yeah, 3 to the 2nd is 9. So that's it. Now, there is another way of doing this problem. Okay, so let me show you another way. Now, when I show you a different way, please don't think that I'm trying to confuse you. I just want you to know that you have options. All right, so let's rewrite this problem. So one of the first things that you can do is that you can address the issue of a negative power inside right here. So when you do that, this becomes 3 y to the 5th over x to the positive 8th power. So what I'm doing here is I'm taking this guy that has a negative power, and I'm moving him into the denominator, so we have taken care of at least one of those negatives. And now what I want to do is I want to take care of the negative power that's right here. I don't want to take care of the 2, just the negative part of that. So here's something neat to know, is that if you have a fraction x over y raised to a negative power like this, what you can do is that you can just use this negative to do the reciprocal, to make this y over x, and then you can apply the power. So again, the emphasis here is that I'm using just the negative part of that power to do the reciprocal of x over y. Because once you get rid of that negative, then applying the power should be a lot easier. All right, so let's do that here. We're going to take this negative factor, just the negative part of that 2, and I'm going to apply it to the fraction on the inside. So when I do that, it turns everything upside down. So we get x to the 8th over 3 y to the 5th, and now this is raised to the positive 2nd power. And now what we can do is that we can just square each of the factors that we have inside. So when I look here, x to the 8th squared is going to give me x to the 16th. In the denominator, remember, this is 3 times y to the 5th, so you have to treat those guys as separate factors. So 3 squared is 9, y to the 5th squared, so it's a power to a power. We multiply that and we get y to the 10th. And that's the same answer that we had the first time we did the problem. Right? Just a slightly different way of doing it, but everything works out to be exactly the same. All right, let's do one more. So this next one involves a fraction and a lot of negatives. So let's see if we can work this guy out using what we've already seen so far in this video. So we have m to the negative second p to the 4th over m to the negative 3rd p to the negative 7th, all raised to the negative 3rd power. So we definitely have a lot of stuff going on here. All right, so let's do this 2 different ways. First, let's do this where we take this power and we apply to each of the factors that are on the inside here. So when I do that, that means I'm going to be multiplying the powers inside times the power on the outside. So when I do that, I'm going to have, let's see, negative 2 times negative 3, so that's m to the positive 6th. 4 times negative 3 is going to make that p to the negative 12th. Negative 3 times negative 3, so we have m to the 9th. And then negative 7 times negative 3 gives me p to the 21st. All right, well, that's kind of nice. Got rid of a lot of the negatives. Then we have this guy to take care of. We do not leave negative, or we don't leave negative powers in our answer. So let's go ahead and address that issue. And as we've mentioned before, with the negative power, we're just going to put that guy on the other side of the fraction. All right, so I already have p to the 21st down here. I'm going to move this guy into the denominator, so that's times p to the 12th. And now we just condense everything. We simplify. So when you look at the m's, it's really a comparison statement. Where do you have more factors of m? You have 6 in the top and 9 in the bottom, so you have more in the denominator. And we have 3 more factors of m in the denominator. So we just do it like that. That's a nice, easy way of doing that quotient rule. Look at your factors of p. Both of these main factors, all the factors of p are in the denominator. So you're just combining these guys. When you multiply, you add those powers because you're saying you have 21 factors of p connected to 12 factors of p. So altogether, we have 33 factors of p. But you got to be careful about how you write your answer. We cannot just leave your answer like this. Your denominator of your fraction can never be empty. So what's understood to be up here is the number 1. All right. Now, again, this is not the only way to do the problem. Let me show you another way. And then we're just going to figure out which way is better. And sometimes you don't even know which way is better until you do it multiple ways. So one of the first things that we could have done is that instead of raising everything to the negative 3rd power, we could try to take care of the negative powers that we have on the inside here first. So what that means is that we're still going to have this raised to the negative 3rd power. And I'm going to take all of these guys that have negative powers, and I'm going to write them on the other side of the fraction. So p to the 4th is still up here. m to the negative second goes into the denominator, so that's m to the positive second now. M to the negative third goes into the numerator, so that's m to the positive third. This guy was in the denominator, now he goes in the numerator, so that's p to the positive seventh. So we just rewrite everything so we just have positive powers. And before this guy comes into play, we can simplify. So if you look at the m's, where do you have more factors of m? We got one more in the numerator, so that's just going to be m to the first. And then here, you've got p to the fourth and p to the seventh, both in the numerator. So that gives me p to the 11th. Be careful about how you write this. Make sure you understand that this is m times p to the 11th. That power of 11 is only on the p, not the m. Alright, so now we've got that negative 3 power to take care of. Well, one of the things we did talk about in a previous example is that this guy is a fraction, and we can use the negative there to do the reciprocal of what's on the inside. So this becomes 1 over m times p to the 11th, and this is now raised to the third power. And so we raise everything to the third power. Of course, 1 to the third power is just 1. Make sure that you remember and understand that this is understood to be m to the first. So power raised to a power means we multiply. So that is m to the third. And then p to the 11th to the third, power to power you multiply. And you get p to the 33rd. So there we are at the very end. No negative powers, nothing left to evaluate, and it's the same answer that we had the first time. Now I think the first way that we did the problem was easier, but again, sometimes you don't really know. You just kind of have to work things out in your mind to see which one's going to take the fewest steps.